Yes. Yes, hurry up. Let's get started. All right. Today, we're going to be finishing up this chapter on Friday. We are going to only work on 8.5 and 8.6. We're done with chapter 8. We have one chapter left for the school year, and we're done with Algebra 1. And we'll start with Geometry Algebra 2 in May.
You said we're going to do 12?
Perhaps, maybe. If we have time.
9?
9 is next month.
And 10 and 11.
We've already done 10.
We did.
11 we'll do a little bit of 10, 11, but not at all. All right. So today I give you your notes because I wanted you to have a neat copy of this because it could be confusing just a little bit. So let's get started. The lesson's being loaded right now. Today's lesson, nothing new. Okay. Now we're talking about the special products, special circumstances of factoring. The first special circumstance, perfect square trinomials. A trinomial, or a tri, is 3. So we're still going to have 3 terms that look like ax squared plus bx plus c. But what is unique about these terms?
It's not ax squared plus b.
It is, but they're all perfect. Meaning, well, what am I talking about?
Oh, they all go in? They all
1, 4, 9, 16, 25, 36, 40, and so on, right? They're all going to be perfect. If it's not perfect, you cannot do it. Example. Really, really easy. Okay, so we have this example right here. X squared plus 6x plus 9, A, B, and C. Now, we're trying to figure out perfect squares. The first A and the last term C are perfect squares. Can I evenly split up x squared and x squared? Yes. X and x. It's the same term multiplied by itself. Can I split up C, positive 9? 3 and 3. 3 and 3 because they're the same terms multiplied by itself. Now, how do I find out the 2 parentheses? Well, look at step 3. The B, the middle term, is 2 times one factor times another factor, 2ac. This is your formula. This is how I know if it works. So here, 2ac. 2 times, what's 1a? X, what's the b? C? 3. All right, multiply first, and I'm explaining why this works. 2 times x times 3.
What, that doesn't work?
2 times x times 3. 6 what? 6x. All right, Justin, look closely. You ready? Do you see 6x in the problem? This is 6x is the same as this b because they are the same, Ethan? Because they are the same, we can split up your parentheses as being x plus 3, x plus 3. Or x plus 3 squared. Now, I'm going to stop right there. How or where did I get the x from?
X squared.
Yeah, right here. And the 3 and 3 came from this. Now, the reason why we did 2 times AC is because if you do this mental FOIL, which some of you need to do on a consistent basis, if you do x times x, x squared, 3x, 3x in the middle, that gives you 6x in the middle. So instead of going through all the extra steps in the middle, if they're perfect squares, you can just check it in the middle and know that this is the answer without going through the other steps. This is just another way to solve. This only works for 3 terms. They have to be perfect squares. A and C have to be a perfect square. If it doesn't work, then it cannot be factored. Go ahead and try out the second one. Sit up. How about you? Sit up. Do I have three terms?
Yeah.
Do I have, is the first term a perfect square?
Yeah.
Yes. How do I know? Because it's the same term multiplied by itself. What about the C? 1 and 1. Okay, this one has a special kick to it. If you look closely, if you do 2 times AC, which is your formula to check, 2 times x times 1, well, what do you get when you do 2 times 1 times x? Positive 2x, right? But here I need a negative. What does one term have to be? What's 1? Negative 1 and negative 1. This has to be negative 1 here because if you think back to what you're asked to do, you want to figure out if these terms are the same. If not, then fix it. So that means your terms, your factors in your parentheses have to be x minus 1, or x minus 1 squared. Because they have to multiply to be positive 1, but they have to add to be negative 2. So the ones have to be a negative. They have to be. Well, then we'll do an exception. Okay. Questions? Comments? Okay, try number 3 out. Now that number 3 has a number in front for A. It doesn't affect the problem. If you need a calculator, please see me after school. Do not rely solely on the calculator. The calculator only helps you do the work faster. It does not do it for you. No, check it again. Picture A. Picture A. No. If you check that mentally, Philip, you will know right away. Think about your signs. You have a minus 12 in the middle. You cannot have positives anymore. They cannot work. So, if we split up A, we get 2x and 2x. Not 4x, not x. 2x and 2x. 2 times 2 is 4. X times x is x squared. Split up 9. 3 and 3. Now, if you use 2AC, 2 times 2x times 3, well, you get 12. You get positive 12x. But look in the middle. I need to get a negative 12x. I have to get a negative 12x. So then what sign do I need to change? Yeah, these 3's have to be negative for this to be the same. So if you think about it, they have to match up. So the sign for 3 have to be negative. Negative 3 times negative 3 is positive 9. Okay, so that has to be negative 3. So then, therefore, your answer is 2x minus 3, 2x minus 3, or 2x minus 3 squared. Only works for perfect squares. The A and the C have to be a perfect square. If it's not, then it does not work. Now, but can you use A times C and do it the regular way? Like what we did on Friday? Yeah, it's the same thing. This is just another tool in your math tool belt. Well, William, did you have a question?
How do you know this is a perfect square?
Well, do you know your perfect squares? Right here? Where am I? 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, and so on. These are your perfect squares. If you need a chart, I have one. Who needs it? Okay, I'll give it to you after class. I have a million of those. Okay. That's from 8th grade. That's from 7th grade, by the way. Now, if you're wondering, well, how do you know when it's not a perfect square? How do you know? Okay. But if you look really quick, it doesn't really. But I have 16 though. That's a perfect square.
But they won't add up to B.
Let's try it out. You ready? Try it out. Let's go and try it out, and I might get this. Split up x squared, please. 16, please. Okay. Now, at first glance, looks kind of, okay. If you do further investigation, 2 times x times 4, what do you get? You only get 8x. You cannot get 9x. Because these are not the same, this is already factored. It cannot be broken down anymore until chapter 9. Until chapter 9. All that means is that when you get the 2 parentheses will be decimals. That's all it means. We'll do that in chapter 9. Try the last one, please. 9x squared. Or no. 9x squared minus 6x plus 4. Again, they're all going to look like they are going to factor out, but the point of 2 times AC tells you, will give you a quick check. If it doesn't work out, it is not an answer. So split up 9x squared. Three x and 3x. Split up 4. 2 and 2. Do 2 times AC. 2 times 3 times 2. 12x. Is 12x the same as 6x? Because these are not the same, already factored. Even if you did 8 times c the other way, you'll get stuck in the middle. You won't be able to factor it out anyways. That's when you know to stop. This is another way to recognize perfect squares. Easier. Ready? Questions?
Well, we always have the option to do this.
Of course, yes. You have an option, yes. I'm telling you, your teachers will be very impressed with you if you know how to factor. You'll be surprised. Alright, last topic and we're done. We'll be out of here very quickly. What's the topic for this one? The difference of 2 squares. Binomial. 2 terms, both perfect, and you have a minus sign. Difference is minus sign. You only can have a minus sign of these. If you have a plus sign, wrong. 2 terms only. That's it. No B. The last term is negative. These are very specific. These are really easy. These are the most missed. Well, obviously they get confused. Okay. Here's why this is. Okay. Really simple. Do I have 2 terms?
Yes.
Is there a B, boy?
No.
Is the last term C negative?
Yes.
Okay. So that I can split it up. X and X. And then negative 9.
Negative 3 and 3.
One is positive, one is negative. Right. It's going to be one is negative and one is positive. That means, all this means is x plus 3 and x minus 3. The reason why one is positive and one is negative is because 3 minus 3 is 0, right? So it cancels out in the middle. That's all it does is just cancels out in the middle. That's all it's doing. Right? Right. Do the second one, please. 2 terms, minus sign, both have to be a perfect square. The first term, please. Be careful.
3x squared.
Why can't it be 3x? Because it's 4. 3x squared, 3x squared. Because you have to get x4, and then the 16y.
Negative 4y and positive 4y.
Okay. Questions so far? Split it up. Right. There's my answer. Because I want the middle to go away, so I have one positive and have one negative. They have to be the same number to cancel out. Nope. Does not matter what order. Thank you for asking. All right. Let's go to the bottom where we're done, because the bell's going to ring. Sorry. These are really simple. Why can't I split up 3? more specifically, is not a perfect square. Okay? Prime is correct, but it's not perfect. 3 is not perfect. What about this 5? Why 5? Why 5?
Can't split it even.
The 5 can't be.
Must be, no, so no odds. Well, not until algebra 2. That'll be y to the 2.5. But anyways. So this will be already factored, right? Look at the last one. What's wrong with the 7?
Both 7.
Again, we cannot have odd. No odd what? No odd exponents. No odd exponents because you cannot evenly split it up. So no odd exponents. And then the 7, it's not perfect. Because it's not perfect, you cannot split it up. I'm done. The bell's going to ring, but I'm going to go over the homework with you really quickly. Let's do as much as we can. The more I do, the less you have to do. I want all of it done. Do it on the paper.
We're doing all of them?
All of them, because they actually go really fast. On this paper. You don't need another paper.
Oh.
All right, here we go. Let's do some of these together. Let's do number 1. I have x squared plus 10x plus 25. Is the first and last term perfect?
Yeah.
Okay. And then I have, here I have x plus 5 and x plus 5, or x plus 5 squared. And the phone rings. Do number 2. Hello?
Oh my god.
2? Yeah. Yes. Bye. Sergio, don't go to the office when we leave.
Okay.
How do I split up 9x squared?
3 and
Okay, how about 1?
1.
And then I need a 2 in front here, so then it's 3x plus 1, and then 3x plus 1, or 3x plus 1 squared. It's very simple. On the back page, again, do it on here. Go ahead and go. Thank you. Really simple. Don't freak out. What happens if it's 2 terms?
then you don't do the 3 term thing.
It's already factored.
No.
Minus sign in the middle, perfect squares, and factor it out. Okay.